I'm really good at technology. Okay, so starting out today, we had our warm-up. So we were asked what type of function are each of these graphs. So this is what we did yesterday. We saw the different graphs. We learned what the names were for each of them. So looking at this first one, we ended up with absolute value. Absolute value. That's our first function. And it has a chart B. Our second graph we have is quadratic. This is our U-shape, and remember this U-shape can be up or down, just like the V can be upside down or right side up. It doesn't matter which one, they're still the same function. And then our last one is our exponential function. So these are three other types of functions, or three types of functions we learned yesterday with labeling. The last one that we don't see was our linear function, which is just our straight line that we saw. Those are the four we talked about yesterday. So yesterday we talked about these different types of functions. Today we're going to look at what happens if we take one of these functions and we start shifting it. We start adding some things to it. So I have this equation, or I have this function here. So this is one of my absolute value functions. And I'm going to call it f of x. So that's going to be the name of my function. Now f of x, I don't need to know what the equation is. I don't need to know that it's going to be like y equals 17x plus 34 or whatever. Like, that doesn't matter. All I need to know is that I have this function called f of x, and this is what the shape it looks like. So I want to know what happens if I were to take that function and I were to add 3 onto the end of it. So I have some equation that I don't know. I'm just adding 3 to the end of it. What is that going to do? How is that going to change my function? Or what happens if I take that same function f of x and I subtract 3 from it? What is that going to do? So we're going to actually go to this website and see what happens when we have our function f of x here. So I'm going to make a new function, f of x plus a, and I'm going to change a. So I'm either increasing by a certain amount or decreasing by a certain amount. Did then my a show up? There it is. So as I add numbers, my function increases, it rises up. If I take away a number on the end, I'm decreasing. So as we saw, we were seeing what happens if we had f of x plus 3. So if I put this at plus 3, I'd be right here. So I'm 3 spaces above my original function. If I have f of x minus 3, I am 3 spaces below my original function. And so both of these work out. So if you're adding a number to the end, you go up. If you're subtracting a number from the end, you go down. So we're going to say this is our function shifted up 3. Our function shifted down. If I can write, maybe down 3. That's supposed to be there. And so if we were to graph these, all you need to do is we can just look at this function we originally have and look at those points on the function. Where are those nice points? And I can take each of those and I can shift them up 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 2, 3. 1, 2, 3. And this would be my f of x plus 3. Or same thing with going down by 3. F of x minus 3 is just going to be 1, 2, 3. All those spaces are going to be shifted down. And so even if we don't know the equation of these functions, we can still graph them, and we can still shift them as long as we have an image to go from. And we can still perform these translations, even if we don't know or have a table or anything like that. So that one was an absolute value function. And we added something to the inside, or the outside. What happens if we add a number to the inside of it? So here I have f of x plus 3, but that plus 3 and that minus 3 are inside my function. If I take it away from the x, how is that changing my function? So once again, in order to check this, if you take a guess, we can go back to our Desmos. That pulls up for me. Okay, here we go. I'm going to get rid of my f of x plus a. I'm going to look at f of x plus b down here. So I have a number on the inside of my function now. And I want to see what happens when I change that number. So initially I had plus 3. So if I look at plus 3, my new function shifted to the left. But if I have minus 3 on the inside, my new function shifted to the right. So this one's a little bit different. So when we added a number to the outside of our function f of x plus a, when we added 3 to the outside, we went up. We subtracted 3 from the outside, we went down. But when we add a number to the inside, if it's a positive number, we go to the left. If it's a negative number, we go to the right. So it's sort of backwards than from our plus a. So this inside is sort of backwards from what you actually think compared to the outside. So if we were to graph these, we have f of x plus 3. So plus 3 means to the left by 3. So I'm going to go 1, 2, 3. And then that's my new function. Or I can go f of x minus 3 like I saw for my second example. And that is to the right by 3. And so I take each of my points and go 1, 2, 3. And then that would be my new absolute value. So once again, the inside is sort of backwards from what you think. If it was positive, you think it would go to the right, but it's actually not. You're going to go to the left. If it's negative, you think you would go to the negative, but you're not. You're going to go to the right. So the inside is sort of backwards of what we thought. So that one's an absolute value. What happens with the absolute value? Now the real question is it going to stay the same if we had a different function, like a quadratic? So once again, this is our second one that we talked about. We don't know what the function of a quadratic looks like. We don't know the equation. But we just have this graphic. But if we were to do that same thing, add 3 to the outside, or add 3 to, or subtract 3 from the inside, is that going to do the same thing? Is it still going to go up or down? Let's find out. Oh, I need to change my pen. So now we have our quadratic here, just like we saw. So I'm going to turn on I'm going to turn this to 0, maybe. 0. Participation. Turn that on. So if I add 3 to my function went up. That graph went up. If I subtract 3 from my function goes down. So once again, this is just like it was with our absolute value. The same thing. Adding to the outside still increases. Subtracting from the outside still decreases. If we look at our inside change, adding to the inside goes to the left. Subtracting from the inside goes to the right. That's still the same, just like our absolute value was earlier. So it doesn't matter which style of function we have, whether it's a absolute value, whether it's a quadratic, whether it's an exponential or a linear, it's still going to do the same thing. And so if we were to graph these, if I were to graph g of x plus 3, g of x plus 3 is going to be up 3 spaces. And so that's my new quadratic. If I were to graph g of x minus 3, g of x minus 3 is going to be down 3 spaces. All my points will be down by 3. And I can look at each of them. So I have these points right here. I can go 1, 2, 3. If you're having trouble figuring out where the points are coming from. So that is our g of x. Okay. So once again, it doesn't matter if it's a quadratic, exponential, absolute value, linear function, those changes are all going to be the same. What we've noticed so far, if you're adding, or if you have a number and it's on the inside of the function, so inside, for example, like f of x plus b we saw, if it's on the inside, if that is a positive, you are going to go to the left. The positive shifts left, like we saw. If it's a negative, that's going to shift to the right. Negative shifts right. That's right. And that's if it was on the inside. If we add something to the outside, though, what happens to the outside, such as f of x plus a, like we saw earlier, we were adding some random number to the outside. If that number was a positive, then we shifted up. We went higher. If it was a negative, we shift down. So we went lower. So these are little things to remember. So if it's on the inside of the function, f of x plus b, If it's a positive, we're going to shift to the left. If it's a negative, we're going to shift to the right. But if it's on the outside of the function, f of x like plus a, like f of x plus 3 or f of x minus 3 that we saw, it's going to either shift up or it's going to shift down. So these rules are going to work for any type of function we see, even ones that we don't know. So if we look at this example right here, I have h of x. So this is an exponential function. I have h of x. So I need to predict what will happen if I have h of x minus 5. So h of x minus 5. So thinking back through our rules that we just talked about, that we just wrote down, we know minus 5 on the outside, because it's on the outside of our equation or function, that is going to go down. So I know I'm going to go down 5 spaces. So I can look at my exponential function. I can find some nice points on there. These are a couple of nice points on my exponential function. I can shift all these down 5 spaces. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And this one's going to be like right there. And so this is my new exponential function. And that would, of course, keep going up and up and up and up all the way up. Same thing. Predict what will happen for h of x plus 2. So now that it's on the inside that we're talking about that. So if we think back to the inside was left or right. Specifically, positive was left. So we're going to the left 2. So I'm going to take all those spaces that I found from my last one, from my original function, and I'm just going to shift them to the left 2. So it goes over, this one's 2, over 2, and that one's going to be like way over here. But because it's off the graph, it doesn't. And this is our new exponential function that got shifted to the left by 2. And so these rules right here that we saw, this like minus 5 or plus 2 with these functions, they work for any type of function you would run into, any one that you might see. So we've only been doing one, so we've only been doing either an outside or an inside, but it's possible to have both. So we have L of x, this linear function here, and I have a translation on the inside of my function and on the outside of my function. So I'm told L of x minus 2, but also plus 1. So I have minus 2 on the inside, but plus 1 on the outside. So once again, we think back to our chart we had. If I'm on the inside, minus on the inside means shift to the right, plus on the outside means shift up. So if I look back to that, we're shifting 2 spaces to the right. So we're going right 2, and then we're going up 1. So I can take some points I have on this graph. I can find some nice points. I can shift these all right 2, up 1. Right 2, up 1. Right 2, up 1. And I'm going to get that same line, except now it's graphed from that translation. Once again, I can do the same thing for the second one. Predict what will happen for L of x plus 4 minus 6. So that plus 4 on the inside, that's telling me left 4. And that minus 6 on the outside, that's telling me down 6. So we're taking every point, we're going left 4, down 6. So I can go 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. No, we're done. Miscounted the last one. So this would be our, I am off. 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. That one's right. These ones are off. This one should be here, and this one should be even farther down. But this is our function if I actually drew my line better. So that's a left 4, down 6. So you can take a moment, you can do the practice. If you have the practice, work on that for a little bit. So once again, this even works for functions we don't know. So here's a function that we've never seen before. It's a function that shows up in Algebra 2 called a quartic. And we're not going to have to visit this at all in Algebra 1. But we could still do these same rules for this function. Even though we've never seen this, we'll never learn this in Algebra 1, we can still use these same rules. So we're told that f of x plus 4 on the inside. That means I'm going left 4. Minus 3 on the outside. Or plus 3 on the outside, I'm sorry. That means we're going, let's see, up 3, right? That's the color. And so I'm going to take each of these points on this function. I'm going to go left 4, up 3. 1, 2, 3, 4. 1, 2, 3. So that's the first point. This one down here is going to be 1, 2, 3, 4. 1, 2, 3. All right, this one. 1, 2, 3, 4. 1, 2, 3, 4. I think that's better. So our function should look something like this. Obviously, it's not perfect, but because these are some hard points to graph. But we can do that exact same thing once again. Same idea, same rules, same functions, doesn't matter. And that's where we'll stop for today.